All right, each page of the book will contain 30 square inches of print. And each page must have 2 inches margins at top and bottom, and 1 inch at each side. What is the minimum possible area of such a page? Okay, so I guess this is something that a publisher might want to think about. They want a certain amount of print. So this is the amount of print that they're going to, printing space they want to have. Okay? But they also need some margins. So they want 2 inches here, and 2 inches here, and they want 1 inches here, and 1 inch here. But they also want to design it so that they're not going to waste so much paper. So the goal is to minimize the paper size, still being able to contain 30 square inches of printing space, and you also have the margins. Okay. All right. Is this an optimization question or a related rates question? Optimization, because you're trying to minimize or maximize. In these optimization questions, what do you look for? You look for 2 things, right? 1, constraint and target, 2 targets. So actually you have to figure out what you want to maximize or minimize. That's your target. Since we're trying to minimize the area, this is your target. And the constraint is somewhere in the problem. Let's think about it after we figure out the target. In order to talk about the target, we should name this side as x, that side as y. Then, how do you write down the target function? Target is the area of the entire thing. What is it? X times y is x times y. That's your target function. Now, since I have a equals to x times y, now I need a constraint that gives me a relationship between x and y. Right? Okay? Here's a number, 30 square inches. That must have something to do with constraint because we didn't use it, right? Now, what is this thing about? What is this 30 about? That's the area that you can print, right? This much. Can you express this in terms of x and y? Okay, so it's basically this length times that length, right? What is this length? X minus 2, because you're taking away 1 from the left and 1 from the right, right? So you have x minus 2, and on the right, for the height, it's y minus 4. Right? And that has to equal to 30. Right? And that's it, we are almost done. How? You have a constraint, you have a target. What's the method? Solve the constraint for one of the variables, plug in the target, so the target becomes a single variable function. And you differentiate, use calculus to find the minimum. That's how you do it. Right? Okay, so let's try that. Let's solve for y. How? Divide by x minus 2. Maybe I should write this down. Target, constraint. Since I have to solve the constraint for y, let's divide by x minus 2. I have y minus 4 equals to 30 divided by x minus 2. And then, if I add 4 both sides, I get y equals to 30 over x minus 2 plus 4, which now can be plugged in over there. That means, after plugging in, I have area equals to x times 30 over x minus 2 plus 4. And our goal is to find the minimum of this. All right, before we differentiate, I should multiply them. So I get 30x over x minus 2 plus 4x That's easier to differentiate. So let me differentiate this now. So raise this sign. Let's differentiate. So you have A prime equals to, this one requires quotient rule, right? So differentiate the high times the low, minus differentiate the low times high over low squared. Actually need more space here. And then if you differentiate 4x, that's equal to 4. Low squared. Okay. And then if I multiply this and subtract 30x, 30x minus 30x will cancel the 30x's. So what's left is negative 60 over x minus 2 squared plus 4.
Where'd you get the 1 from?
1 is because I have to differentiate the bottom.
Oh.
If you differentiate the bottom, it's 1, right?
Oh, okay.
So to illustrate what I'm trying to do, the quotient rule is however low differentiated is highly low minus low d high over low squared. That's one. All right. Okay. So that's the derivative. What do we look for now? To find the minimum, what are we looking for? We have to find the critical number. We have to find the critical number. Okay. So set this equal to 0. Let's solve it. You have, let's see, negative 4 equals to negative 60 over, no, I like the other way better. Let's move this over. So you have 60 over x minus 2 squared equals to 4. Now multiply x minus 2 squared and you get 60 equals to 4 times x minus 2 squared. And we're almost there. Divide by 4, it's 15 equals to x minus 2 squared. Take the square root to get square root of 15, so you get x equals to 2 plus square root of 15. So that's the point where you get 0. Now, to see if this really does give you the minimum, we should try the following. We should put the number line. And by the way, x cannot be 2 because if x is 2, then this will be 0. You wouldn't have any printing area. So x has to be bigger than 2. So x has to be something bigger than 2. And here is 2 plus square root of 15. And let's try to find this. This is your a prime. Let's try to find your a prime's sign before and after 2 plus radical 15, because that way I can be sure if this is a minimum or not. Okay. So I guess when x is 3, it's before this. So let's pick a test point 3. Plug it in here. What do you get? You get negative 60 divided by 1 plus 4. That's some negative number. Definitely negative 60 is, negative 60 plus 4 is negative, so I don't care about the exact value. All I know is it's negative. And then put something like 100 as a test value for the other one. If you put some 100, this is very, very small, right? 100 squared is like 10,000. So 4 minus 6 over 1,000 or something like that, that's going to be still positive, right? So you have a positive here. And these two test points tell us that A decreases before 2 plus square root of 15 and increases after 2 plus square root of 15. Therefore, what can this be? It has to be the minimum. So we know that this is minimum. Such calculation is necessary because you can't just say, oh, here's a critical point, that's the only one, so that's probably it. Then, I mean, that lacks any logical reasoning why this does give you the minimum possible value. Okay, so we're almost done. Now, when x is 2 plus radical 15, what is the value of y? You plug into constraint to find the value of y, right? So if x is 2 plus radical 15, let's plug x in here. Minus 2, y minus 4 equals to 30. So y minus 4, this will give you square root of 15, and you divide 30 by square root of 15, which is 2 radical 15. So you get y equals to 4 plus 2 radical 15. And then finally, your target value, the minimum possible area itself, is the answer is 2 plus square root of 15 times 4 plus 2 radical 15. And this is square inches. Right, I should have pulled my calculator out, but you should use your calculator to figure out what this area is in decimals. That will give you the approximate value.